Welcome back. This time we're going to be looking at sine, cos and tan. Now you will have seen those buttons on calculators, but you may not know what they do. Sine, cos and tan are all about ratios within triangles, but again, we're looking only at right angled triangles at the moment. Later on we'll look at non-right angled triangles, but for now, these rules only apply to right angled triangles, so make sure you keep that in mind. Now, you'll notice this weird little acronym I've written up the top of my page. This is the number one thing you're going to remember that's going to help you solve all of these different problems. It is just a little acronym to help you understand which bits go with which ratios, and I promise it'll make more sense over time. So, SOHCAHTOA, that's what we're going to remember. This one is sine, this one is cos, and this one is tan, okay? So, this one is going to be sine, this one is going to be cos, and this one is going to be tan. So let's start with sine. So the first thing I'm going to do is write a little symbol in one of the angles. It doesn't really matter where I write it, but this is a little Greek letter called theta. So I might just write that up the top. And it just means an unknown angle. So theta is one of the symbols that we commonly use for an unknown angle instead of things like x or y or z, which we normally use for an unknown side length when we're talking about trigonometry. So we use letters for side lengths and we use Greek letters for unknown angles. So we might also see something like that, which is beta. You might also see something like this, which is alpha. So these are just to help us tell the difference between angles and side lengths when we're looking at diagrams. So this just means we don't know what this angle is. Now, when you're labeling a triangle, before I get into that, I'm just going to draw another triangle over here and another one over here where I label some things. Okay, so if I put the angle there or the angle here, the sides of my triangle are going to be a little bit different. Now, we talked before about the hypotenuse. It's always the longer side and it's always opposite the right angle. So this side here is my hypotenuse. And same over here. So that bit's easy. Now we just need to be able to label the other two sides. Now, the next one is really easy as well because it's called the opposite side and it's always opposite the labeled angle. So in this case, it's over here. So whichever side is opposite the angle that you're given, that's the side we're going to call the opposite. So for this second triangle, it's actually the other one, right? Because I drew it over here, which means this one is the opposite side. And the other fancy word we use is adjacent. If you're unfamiliar with that word, it just means next to. So this side, the leftover side, must be the adjacent side. And same with this one here, adjacent, because it's next to the angle, right? Adjacent just means next to. So if I'm going back to my little triangle over here, if I've labeled this one as theta, that makes this one the hypotenuse. And it makes this one the opposite. And these are the only two sides we need to use the sine ratio. As you can see here, we've only got O and H when it comes to sine. So this is the opposite and this is the hypotenuse. All right, I'm not going to write out the whole word, but you get what I mean. So the rule is sine of the angle is the opposite over the hypotenuse. And that will become apparent what that means in a minute. Don't worry too much about it. That's just what the rule is, okay? So sine, again, we're just pressing buttons on our calculator. It's about ratios. You don't need to know how to calculate this by hand. But sine of whatever we get told this angle is, this is just a generic example, but we will get given a value at some point. Sine of whatever this angle is the opposite side divided by the hypotenuse side, all right? And you'll get some lengths and we'll go through examples. Okay, same thing. Let's say that I put the theta there again. I'm just going to label this. So this one can be sine, this one can be cos, and this one can be tan. All right, so if I've got theta here I want the adjacent and the hypotenuse. So again, this one's the hypotenuse. The opposite side is over here again, but I don't want it. I only want the adjacent. So for this one, the rule is going to be just the same as this, but it's cos this time. So cos of the angle, and this time it's the adjacent divided by the hypotenuse. And again, I'll show you how to use that in a second. And this one here is tan. So if I put that there, This time we don't want the hypotenuse at all. We only want the opposite and the adjacent sides. So this one is going to be the opposite, and this one is going to be the adjacent. So tan of theta, whatever the angle is the opposite side divided by the adjacent side. All right? So these are the rules that we're going to use, and I'm going to show you how to use them. All right, so let's say that I have a triangle. Let's start with sine. Okay, so I'm going to call this, let's call this 40 degrees. I'm going to call this my unknown, and this can be 10 centimeters. Okay, so I do not know what this length is, but using sine, I'm going to be able to find out. So my generic rule was this: sine of the angle equals, remember, SOH. So it was sine, oh, I didn't fill in these ones, did I? The adjacent over the hypotenuse and the opposite over the adjacent. All right, so my sine rule is, actually, sine rule is something else. Ignore I said that phrase. The rule for finding an unknown side when using sine is this. So sine of the angle equals the opposite side divided by the hypotenuse side, SOH. So that's what I'm going to do. I'm going to use the opposite side, which is my x, right? That's my opposite side, over the hypotenuse, which is 10. Oh, why did I write theta? We know what theta is. Theta is 40. So I'm now going to use my linear algebra skills to get x by itself. So if x is currently being divided by 10, what's the opposite of division? It's multiplication. So I'm going to bring 10 across, and I'm going to multiply 10 by sine 40. And then all I do is type that into a calculator. So if I've got this here, all I'm going to do is, your calculator will look different to mine, but I'm going to type in 10 times sine 40. And my answer is 6.43. So that means it's 6.43 centimeters long. That's what that side is. All right, let's have another go at one of those. Let's draw it backwards. Okay, this time I'm going to write the angle down here just to prove my point. If we call that 35, let's call this 13 centimeters, and let's call this one x. Okay, so again, this is sine because I have my opposite side and I have my hypotenuse side. So sine of 35 degrees equals my opposite side, which is x, divided by my hypotenuse, which is 13. So now, using my linear algebra skills, I'm going to bring 13 across and multiply. So 13 times sine 35 is x. And again, I just type that into my calculator. 13 times sine 35 is 7.46. So that means it's 7.46 centimeters long. Now, you should be able to check your own work a little bit with this. So if I got a number that was bigger than 10, I would know this is wrong because the hypotenuse must be the longer side. Same with this, it's got to be less than 13 because the hypotenuse has to be the longer side. So this makes sense to me. All right, so what if I don't know my hypotenuse, but I do know my, my opposite side? I'm going to draw this one upside down. Okay, so let's say that this is my unknown this time. I'm going to call this one 26 degrees, and this is going to be, let's call this pizza. Okay, so if I don't know this one, I'm going to have to write it exactly the same way, but I'm going to have to solve it slightly differently. So again, sine of my angle is my opposite over my hypotenuse. Now this time my x value is on the bottom of my fraction. So I'm still going to do exactly the same thing. I'm always going to move the bottom of my fraction first. I'm not going to try and do anything with the top because that's when I'll make mistakes. So again, I'm going to bring this across as a multiplication. And then what I'm going to do is bring this over here as a division, because if x is multiplying sine 26, well, I want to get rid of it because I want to get x by itself. So the opposite of multiplication is division. So this time I had one extra step to do, but again, I'm just going to type this into my calculator. Whoops. So I have 8 divided by sine 26, and I get 18.25. Now, again, this makes sense to me because this should be the longest side, right? This is the hypotenuse, so it should be much longer than this one. Maybe not much longer, but I do know it's longer because of the size of this angle, but don't worry about it. So this must be the longest side. So this makes sense to me. All right, let's do one more.